Now we're live on YouTube. That is great. I will do a tweet and I will share my tweet here as well if you guys want to retweet, or if you guys want to do your own tweet, that is also fine. Welcome to the threat modeling tools demo session on Wednesday morning. We will have another one in the afternoon, UK time. We are joined by Izar and Fraser, and Stephen has been quite crucial in organizing this session, so thank you, Stephen, as well. So guys, take us away. What do you want to talk about?
Okay, I guess I'll go first. Yeah, so today I would like to demo PyTM. Can everybody see my screen? Okay, so this is sort of going to be a bit of a stream of consciousness more than a demo, because I haven't demoed this in a while to be sure. As we said, questions in the middle are more than welcome. It's 6 in the morning here, so I'm a bit out of it, but I'll try to keep to the agenda as much as possible. So first, a bit about threat modeling as code, and some words about 3 different approaches that are out there. Going to talk about how PyTM came to be. It was a niche and we got to scratch it demo, and then talk about where we want to go and ask you guys to participate and to collaborate. So threat modeling as code. Let's jump in here. Nowadays, we want everything as code, everything infrastructure as code, code as code, everything. So the people who came up with PyTM in the beginning, we started to ask ourselves, wouldn't it be cool if we had threat models that evolved together with the system that they represent? And if developers themselves, and not the security team or the security champion or the security X, would be able to maintain the threat models and add features or changes from the system to the threat model in real time, and do that in a natural way. So this way, the threat model could become a part of the system documentation as the system was developed. And the big question was, okay, how can we do this so that it's easier for developers? We worked very closely with developers. We're developers ourselves, and there was always that lingering feeling that for a developer to stop what they do and to stop coding, to take a step back, go and open a GUI and start drawing things on the GUI and breaking that connection that they have with the code that they're writing or the system that they're designing, was sometimes a bit of a barrier for the developers to engage with threat modeling. Plus, we wanted something that was easy to keep on a code repository, to look at changes, to basically what we wanted was code. And we looked at a couple of use cases that we had for a threat modeling tool, and something that would work both on initial discussions on threat modeling when the system is in a room or remote and discussing just initial designs and let's do it this way, no, let's do it that way, something that could work together with that dynamic. Something that, of course, would help developers maintain together their code, and something that would serve as peer documentation, something that would provide those reporting capabilities that a usual threat modeling tool or that an artifact from a threat modeling process would create. So looking out there today, there are 3 main distinct approaches to threat modeling as code. We're going to see soon, Fraser is going to show us a threat spec, which in my opinion does threat modeling in code. You have code and you use that code to inform the threat model. Then we have Abhai's threat playbook, which again, in my opinion, does threat modeling from code. So the code is in place, the system is working, you use all kinds of artifacts to build a threat model from that. And then there's PyTM, which does threat modeling with code. You write code, you end up with a threat model. The people behind this, the main authors were Matt Coles, Nick Osmore, Rohit Shambhuni, and myself. We have 2 amazing contributors in Pooja Arpad and Jan Bas. PyTM has started in 2018, sort of, and it started as a Pythonic way of creating threat models. The things that we wanted to have it do for people were, first of all, work like a traditional Unix tool. That means it does only what it does, doesn't try to do more, doesn't try to do anything less. It's basically write this thing, get this output, get your threat model. We try as much as possible not to associate it with any existing threat modeling methodology. So if you do Stride, if you do Pasta, if you do whatever, it should be useful for you in some way. And again, it's from developers to developers. The only difference here is that it's from developers who are more on the security side of things. So we try to talk to developers who are not. The basic idea is that we have a bunch of elements. These elements have attributes, and these are represented as Python objects, which at this level, it's not precise to say Python objects. What we were looking at was a way to express object-oriented approaches to describing objects. So the usual object.attribute equals value. And that, of course, anybody who has any kind of exposure to any of the many object-oriented languages out there should be able to write this code. So if the developers write Java, if they write Python, JavaScript, whatever, they should be able to look at this and say, okay, this is close enough to what I do every day that I'll be able to write it when I need it. The attributes themselves try to be as self-explanatory as possible, but we are developing more documentation to support that. We'll see on the demo. But things like, is this server encrypted itself? Or does it authenticate the source? Or does it implement the principle of least privilege? We are constantly adding more elements and more attributes. It's a whole cycle thing of how do we express this threat? We need a new rule. The new rule needs a new attribute. The attribute leads us to perhaps a new element and all other interactions of that. And okay, let's see what it looks like. Do you guys see my Visual Code window?
No, we still see the presentation.
And then wait.
You might need to stop share and reshare.
So let's share the whole screen. Okay, now you see everything?
Yep.
Okay, cool. So let's close that, bring that one down. Okay, so this is what it looks like. Basically, your good old Python script.
Can you make it a little bit?
It starts by importing a little bit bigger. How do I zoom on this thing? Does anybody remember?
Oh, zoom in.
Better?
Oh, but the writings are still small. So the, in that same menu, there was a zoom in option.
Zoom in. Oh, there it is.
Thank you. I can read that. So
Better?
Yeah. Is that
okay.
Good for everyone?
So
I hope so.
So we start by importing those elements that we're going to use in the script, and by identifying, describing the initial object, which is the threat model itself. Jump all over the whole thing as long as we close with a call to TM process. Sorry, that will get the thing running. So in the middle, what we have is we define the elements, and then we populate these elements with their attributes. The good thing about this is that if you use an IDE, you get all the attributes as part of the completion. So for example, for an actor, you can have handles resources or implement an authentication scheme, implement a nonce, is in some kind of trust boundary, is in scope for the threat model or not. So you can create attributes, elements that exist but are not in scope for the threat model, and so on and so forth. Anything interesting here? You create your data flows, so how the elements talk to each other. And in the end, as I said, you call TM process. So the point of the thing is that today it can create DFDs, sequence diagrams, and a full report. The report is actually created using a very basic template language that we shamelessly stole from another project, attribution in the code. But basically what you do is you build your template in whatever output you want. You want to create HTML, you want to create Markdown, whatever, as long as you use these constructs, you're able to access what comes from PyTM. So this is the sample make file, and it shows how things happen. So if you just invoke your script with --DFD, you should get just the DFD. Same thing with --sec, you get just the sequence diagram. --report calling for the template, and you get whatever you put in there. So if we see that.
You have a question, is this code in public repo?
Sorry?
Is this code in public repo?
Yes, yes, we'll get to that in a second.
Thank you.
So these three commands are enough to create a whole report. Of course, you can just do them in any order and at any time so that you can see exactly what you're doing. And my fingers today. And the end result is this report. System description, the same one that comes from, that comes from this definition here, for example. Then you have your DFD, a sequence diagram that's generated basically from the same DFD. A list of your data flows as defined. And then you have the potential threats that were identified in that model. So this is the sample threat model that comes with the code. So it has a bunch of very explicit threats. For each threat, you have the description, the mitigation, and the references. These come mostly from attack and from KPAC. And that's basically what it does, what it is. We, in the last summit a year ago, I think that we had 10 threat rules. Now we have, I believe, 100. Bear with me.
You have a couple questions.
Yep.
In the chat window. Do you want me to read them, or are you happy?
Yep, go ahead.
So are there any attributes that are required and it won't work without, such as whether TLS is being used or which version of TLS is one question.
Sorry, are there any what?
Are there any attributes that are required so that it doesn't work?
Required.
Yes.
No, we for every element we have a set of defaults, and you can tweak them as you run if you forgot to define something. So if you see something, a threat that you weren't expecting, then you go back to the code and say, oh, uses TLS equals true, fine. So that gives you that iterativity on the threat model itself.
Thank you.
Then we have the public repo. Yeah, it's in GitHub. We are right now getting into all the framework for being an OWASP project. We started with the web part, and soon we're going to settle the things with the repository. But not right now. If you go to GitHub and look for PyPM, you're going to get there. Yeah. Okay. Any questions on running or anything like that?
Not currently. Not currently.
Oh.
I'm also monitoring the YouTube chat. There are no.
Where do we want to go with that? Sorry?
There are no further questions at this moment.
Okay. So what we are looking to is to integrate with other tools. We would like to be able to get input and output from other useful tools out there. For example, there is a JSON to Python script being worked on so that people could define their systems in JSON and end up with the equivalent threat model in Python. We are always looking for more threat rules. As I said, last year we had 10. Today we got 100 and going up. More specialized elements. We are working on getting some elements that go beyond the usual things that you see on a DFT. You guys saw on the sample, we already have a Lambda one, for example. We are working on some other stuff. And more use cases. We want to learn how people are using this or how they want to be using this so that we can try and accommodate that. Soon there will be more about, sorry, there was a question there?
There is a question in the chat. Can you show the workflow for addressing threads and how to annotate each thread with its address?
How to annotate? I'm not quite sure. Perhaps who did the question, who asked the question, can you elaborate on that, please?
Exactly, and you can unmute and ask as well. It's always better. Dear NA, do you want to unmute and ask? I guess not. So
okay, so a bit about the threads then. We have this JSON file that defines the threads, and the basic structure is very clear, very easy. I think that the interesting parts here are to which kind of element each thread applies to. So, for example, this one is for lambdas and processes. And where is the?
They have followed up with the sentence. So to show how each thread is addressed by your code. So a workflow of addressing the thread by changing your code, I think.
Okay, so the condition for each thread is basically a Boolean expression in Python. So this one, for example, uses the target uses environment variables attribute. And if that's true and the target doesn't sanitize input and it doesn't check input bounds is false, sorry, it doesn't check input bounds, then this whole thing evaluates to true, and that comes out as an identified threat. So the way to address that and to mitigate that after you do the mitigations is to go back to the script and make sure that these are true or false and false. So by negating the condition, we basically work out the threat. We also have a way in the command line to say these threats don't interest me. So you can give a bunch of identifiers and say I'm not interested in these threats particularly, and those are not evaluated. Does that answer the question? Yes, no, perhaps.
You can also use the yes, no buttons in the participant window. Oh, and they said yes.
Okay, thank you. So yeah, so as I was saying, the shameless plug, anybody wanting to know more about PyTM, it's going to be part of one of the chapters of this book that we hope to put out on Q3, somewhere around, I don't know, September, October, hopefully. And that's it. Updates come out either on my tweet feed or on threat modeling at the OS Slack. It's a module available on PyPy, and there is a dedicated Slack for developers. So direct message me, and I'll send you the invite. Okay, we are always looking for people to come and help us and work on this. We think there's a huge potential. People have been very receptive of the whole idea, so we're looking to make it the best that we can.
Would you be able to share the repo, link to the repo in the chat window so I have it? And maybe
sure.
even your Slack invite if you want people who visit our site to join your Slack.
Yeah, the Slack is not fully open yet. We are still working on it, so people are invited to contact me and get the invite.
Okay. So people would need to DM you on Twitter, or how would they best? Okay.
Yeah, just DM me on Twitter or reach out on the threat modeling channel on the OS Slack.
Okay.
Or DM me on the Slack there.
Great. So before we move on to the next one, and our next speaker has been called to another call, so we need like 5 minutes. We need to give him 5 minutes. So I'm really interested to hear any questions from any of you guys.
Let me start by asking the question, do you think it's feasible in the future to have some additional interfaces in the code? For example, to say, okay, now I generate this list of threads, I want to do my follow-up, so now I want to import it into something like Jira, Redmine, the Microsoft bug tracking system, something to that nature? Are you thinking about these things?
That's a great question, and I think that I'll bring it back to the initial philosophy of the thing. It wants to be a Unix tool, so it wants to do just what it does. If people want to, in their own threat model script, go and connect to Jira or something like that, they are welcome to. But I don't think that it's the kind of specialization that we want to embark in. That can change in the future. That's sort of where we are right now. I think we got things that are a bit more not important, but come first in our roadmap than going that way.
I think that's a great way to explain it. You do probably want to keep this focused and not add a bunch of functionalities in. It will be a never-ending story anyway, because some people need Jira, some people need something else.
Yep. I can tell you that that's the exact way how I'm using PyTM. I extended it heavily, and that's how I'm trying to contribute some of that to the upstream. But I do modify and extend it when building models in my company. And for example, we do sync the reports to Confluence. So I have a script that just uploads everything to Confluence. Like I could do the same to create some Jira issues out of the threads found, but this is how we do it. But I know this is very specific to us, so that's not something that would make sense to be contributed.
Jan,
Jan is our leading contributor, and then sometimes we have to ask him, hey, wait, you're going too fast. So he's heavily extended the code, and a lot of the new things that we have in the last year are due to his contributions. So thank you.
Jan, I'm curious about what your role is in your company. Are you just a developer, or do you have security responsibilities assigned to you?
I tried to get into security, so I started. I found PyTM. I started using this for this purpose a few months ago, and I'm still learning. So I am primarily a developer, but I'm like I took the security role. So I'm doing threat modeling for the product we're working on.
It's great to have people like you. Questions, comments?
I believe that Fraser is back.
He is.
Yeah.
Thank you. Sorry for that. Yeah.
So I'll get down from the soapbox. Thanks, everyone. I hope you find some use to this, and we'll be glad to hear from you.
Thank you so much.
Thank you, Izar, for the not just for showing up, but also for the work that has been done. Because let's all remember, this is open source work. So for a lot of us, it means work that we put in our free time. So thanks a lot.
Pleasure.
Exactly. Thank you for all your contributions to the world. We're changing the world. One line of code at a time. Okay, Fraser, we are ready for you.
That makes one of us. Right. What am I sharing? So full disclosure, I'm doing this on a Chromebook. So I don't think I've ever shared a screen on a Chromebook before. I'm assuming it's going to work. Okay.
Are you on a client or in a browser?
Can you see that?
Yes, we can.
It's a miracle.
Cool.
I haven't got a shiny presentation, unfortunately, but to be fair, if I did, it would probably look like mostly like Izar's anyway. As he said, threat spec is one of the three approaches to threat modeling as code currently in existence. So in some respect, it's attempting to solve a similar kind of problem, and I'll sort of give you my interpretation of that problem as a starting point. I'll also explain where threat spec came from specifically, and why and you know how threat spec came about. The sort of origin story for threat spec was I was working on a different open source project, which was it was an open source sort of cloud native certificate authority tool, so you could run an internal certificate authority in a cloud friendly way. This is literally just before Let's Encrypt came out, so I sort of abandoned it at that point. Okay, up here. Right, hang on. Right, I'm walking as I go. This is a COVID world. So, yep. Threat spec. Well, so this tool I was developing was very security focused. It was. Am I still connected? Yes. It was, you know, you're talking about certificate authorities and ensuring that those are well managed, etc. So wanted to make sure that the security was in a good state. And, you know, having recently learned about threat modeling, in order to understand this, I wanted to make sure that I was developing a threat model for this open source project. And I didn't want to do it in a way that was, you know, constantly getting out of sync. I didn't want to create a Google Doc or a Markdown file that I had to manually maintain inside a Git repository. I wanted to be able to keep the threat model living with the code, because that's where people contribute in GitHub, for example. Developers will be contributing to code, they will be making changes, pull requests, etc. So I wanted a way that would allow that threat model to evolve with these contributions from people across the world in different time zones, etc. So what I started doing was just annotating decisions and thoughts in the code as comments. So, well, I'm using the pseudo random number generator in order to mitigate a certain kind of threat. So if I can just comment that fact in the code alongside where my pseudo random number generator is used, then that's an interesting point that I can pull out of the code and represent as a threat model. So what I ended up doing is just annotating a whole bunch of functions and methods and classes or whatever within the code with threat modeling context. And then I wrote a very hacky Ruby script that would go and search through these Go source files for these comments that were formatted in a certain way. So it was basically just a Ruby file, a Ruby script with a bunch of regular expressions, and it would extract those and turn that into a Markdown file. So that was where it kind of came from. And then that Markdown file lived alongside the code and was, you know, in theory, always up to date. So a very similar idea of ensuring that, you know, as a developer, or not that I'm really a developer, but as a developer thinks through their application, they're making decisions, they're making assumptions about the security of the code. And as Izar said, you know, in this world, everything is potentially code. So this applies to CI/CD configuration, it applies to AWS, it applies to containers and all of that kind of stuff. As you're working through that, being able to annotate and capture those assumptions, those questions, those challenges, and those potential threats that you're thinking of, and then extracting those out into a coherent threat model is where threat spec comes from. So it's a specification language for threats that lives inside of your code. So what you're looking at here is the website, threatspec.org. It provides a bit of a description and a bit of an example. I'm going to get quite quickly into the demo in a second. The GitHub README has quite a lot of context around how you use it, how you install it. And it uses this annotation style within the comments that you put in your code. So you have to make sure that you're using the right structure. And then it's automatically able to pass out those comments. So there's a fairly comprehensive example and set of annotation rules and descriptions, etc. So you can do single line comments like this, which is nice and quick and dirty. You can say, well, we're mitigating this component against a certain type of threat. You can do multi-lines within the same comment. You can do inline comments. So adding a comment towards the end of a line of code and just say, okay, we need to review this, for example. Is this a security feature? Is this a security bug? Do we care about this? Why is it 644, for example? But you can also use YAML and JSON. So it's actually, you can embed threat spec into existing YAML or JSON files as well. So it's not just, it's not just like classic code like JavaScript and Go and C, but you can also embed it in those sort of declarative languages as well. Here's a summary of all the different features, if you like, within the threat spec annotations. You've got components, you've got threats, you've got controls, and then a mitigation will mitigate against a particular threat against a component using a control. A threat against a component that hasn't got a control is exposed. So we're building in that threat modeling language of mitigations, exposures, acceptance, transfers into the annotation language as well. And we can also describe the relationship between components with this connects concept. We can also extend the annotations with a YAML-like structure. It is actually YAML. So where a description, in this case, mitigates ends with a colon, we're actually opening that up to a YAML data structure. So we're now able to extend that mitigation description with a fuller description that's multi-line compatible, etc. And we can also introduce labels, arbitrary labels, whatever you want to call them, using more of those sort of key value pairs. So we can say the impact is high, the owner is engineering, the reference is some sort of JIRA number or whatever. So you can add, I think initially, there's very little support for that other than description, but you can add as much context as you want to these different annotations. And then you run threat spec against that and generate your threat model. Any questions at this stage before I jump into the demo? Can anyone still hear me?
Yeah, we can.
Cool.
And
right,
I do not see any questions.
Okay, cool. So what I have here is a Git repository. I've got a very simple Go application. Let me do that in Vime. So you can see there are some comments in here already. So I've got a threat of arbitrary file rights. I've got a threat for cross-site scripting, and I've got a control for web application, like a web application file or the WAF. And then I can leverage those threats and controls later on in my actual comments. So we can see here we've got an accept, we've got a mitigates, and it's using one of these probably uses the file rights as a new threat. Arbitrary. Let me find the WAF. So here we've got a control that references the WAF that we've got in place. Where's that? Oh, not using that one. What's file rights? Yeah, so this accepts actually references the threat that we defined above. So we can declare a threat outside of this or in a library, and I'll show you that in a second. And then we can leverage that throughout the source code. 1 minute, please.
Sorry, I got the date wrong. It's actually tomorrow. Okay. Can you make sure you're free tomorrow at 11:35?
Fine. Yeah. Sorry about that. So we've got a bunch of annotations in here. I haven't installed threat spec here, so the first thing I'm going to do is install threat spec, which is just pip install threat spec. It will pull the latest published version, which is 0.5 at the moment. Now, as you can see, we've only got source code in here. That's it. So first thing I need to do is initialize threat spec in this repository. So I'll do threat spec init. Oh, that's not right. Init. And what this does is creates a threat spec.yaml file as well as actually a threat model directory. There's nothing in the threat model directory yet, but we've got a threat spec YAML file. What this does is describes the sort of the threat model context for this repository. We can give the project a name. We can give it a description. We can import threats and controls from other repositories. So where we've got, let's say you've got a fairly complex application that has a front end repository, a back end repository. Maybe there's another GitHub repository for a bunch of CI/CD stuff. Maybe you've got a GitHub repository for some cloud stuff. You could, rather than, because the code lives inside these different repositories, you want to be able to pull that into a single threat model at some point. So what we can actually do is we can import those threats and controls that are identified elsewhere and represent them in here. The paths is the folders that we will scan for source code and generate a new threat model from. So we're going to simply change this to, in this case, just that Go file. But I call it simple web.go. Simple web.go. If I now run threat spec, it will go and pass the source file. We're not importing anything from other repositories, but like I said, you could import it from any number of repositories and create a really, really big threat model from a whole bunch of arbitrary repositories. And you could do that in a nested way as well. So threat spec run. Obviously, there's help documentation sort of built into it. So we can see there's 3 different commands: init, report, and run. So I'm going to do threat spec run now. So this has created a threat model.json file, and it's also created threats, controls, and components JSON files, which should be fairly explanatory. So this contains the array of mitigations, exposures, transfers, and acceptances. And then obviously these IDs are referred to by those threats and components and controls within the rest of the library. We also capture the source of where that was found. So there's source code and file name and line numbers and all that stuff captured. In the threat model, we can see those other files like threat model threats. These are reusable. These are what you could import potentially from other repositories. So maybe you have a repository that's simply a library of different threats, and you could reuse that library across any number of projects and just re-import those threats from as you use them. Other people can then contribute back to them, for example.
I have a question.
Yep.
And this might be a stupid question, but I'm not afraid to ask it because I'm not a coder. So I saw you have threats and controls files.
Yes.
So were they created by your tool?
Yes.
Okay.
Yeah. So what threat spec has done is it's passed the source code. It's identified the definition of some new threats, new controls, and new components, and extracted those into a place that they can be reused. And then it's created that threat model.json file, which relates all of these different things together in that specific context. So the threats, controls, and components are potentially reusable, and that's why they've been separated out. And the threat model then is the relationship between all of that back to the specific source code files.
That is really cool.
Yeah, and as I said, you can then import different threats, controls, and components from different repositories. So you could have a AWS repository which contains a whole bunch of components, for example, or and that's fine. Let's say there is an AWS repository which has a whole bunch of components, but you're threat modeling a new AWS service that nobody has used yet, you can refer to it in your threat model and it will generate a new component within the context of your threat model. It'd be interesting to find a way how to contribute that back, but at the moment it's just sort of text files and JSON files, so it's pretty straightforward. You're only one pull request away. So
yeah,
we've got.
I have another question.
Yeah, go for it.
So this has been in use by people, right? So do you get feedback about how much false positives they see and stuff?
So there's no real. So this is where this differs quite significantly from things like Threat Playbook. I think there is no real false positives, because what it is simply doing is it's a specification language. It's an annotation language. All it's doing is extracting the context that you've provided. You're simply it's not automatically trying to say, because you've got this component, you've got a whole bunch of threats to consider. That would be a pretty cool feature to get to at some point, where you can sort of query those libraries. That's something that's I've thought about but haven't got as far as yet. So being able to query a library through the tool would be good, and you could use that to say, okay, show me some threats that may be related to the components I have, based on what I've imported. But it doesn't sort of try to automatically pull in and give you about 100 controls or 100 threats to go and work your way through. It's really about capturing the context that you're in without leaving your IDE and without leaving without breaking that thought flow, but then being able to generate this more holistic view of a threat model at that point in time. If that makes sense.
It does. You would have to go through them anyway, because you know your business logic and nothing.
Yeah. Again, there is opportunity to do some cleverer stuff with the imports of these libraries, but at the moment we're simply saying, I'm writing a web server application, a web application. I need to query a database. I'm going to use an ORM because it helps mitigate against SQL injection. That as I write that ORM import, like library import, like SQL Alchemy or whatever, I could make a note of why I am doing that, why I'm making that decision, or and describe that in terms of the threats and the mitigations that introduces. It's also from again, if you take a step back, if you've embedded this into a CI/CD pipeline, then a security engineer could be looking at the latest threat model as generated by whatever pull requests that have just been merged, and they could look at the code and the threat model and say, hey, I'm not quite sure about that. Why are you doing that? And submit a pull request against that piece of code with the comment that says, at review, what's going on here? I'm not sure I understand this piece of code. Can you describe it, please? Or something like that. So we can annotate and create those feedback loops between security and developers through code. That's sort of one of the aspirations. This whole thing is very experimental. I've spoken to a number of organizations and people I know in different organizations that are looking at it and have experimented with it. It's, as far as I know, it's not in any sort of widespread adoption at this stage. And full disclosure, I mean, I literally, my full-time job is threat modeling at a Fortune 100 company, and I haven't had a chance to work on this for about 9 months because I just haven't had the time. So if anyone is interested in contributing, I'll be more than happy to support you and help you understand the code base, which is a little bit stale, but I've got some stuff in flight. Anyway, let me generate the report. Again, very similar. So threat spec report, what this will do is pass those different JSON files plus any of the import stuff potentially, and then it will generate a markdown file by default. Again, there are a few options. I can generate a text file, I can generate a template, or I can generate a JSON file as well. Again, similar to PyTM, possibly even using the same. It's using a template engine, so you can, if you don't like the Markdown report, you can generate your own template and reference that template instead. So you can customize what these reports look like using that templating language. And if you look at the source code, you can just see what the default template looks like and just modify that if needed. So we've got a threat model Markdown file, which is what you'd expect. And we've got a diagram, which I'll show you here. On a Chromebook, it's not very easy to look at Markdown files, so I'll show you the one that's in this repository in GitHub. This is roughly what the Markdown report would look like. There's our title from the project from the threatspec.yaml file. Here's that description from the threatspec.yaml file. The diagram is then generated based on those mitigations, those controls, and those threats and their relationships with components. So you can see what threats there are, which mitigations we have, and what threats and controls those mitigations relate to, and which components those are related to. We then have a textual representation of a lot of that. So here are the exposures. We've got an exposed cross-site scripting threat against the web app application component, and it shows you the code where that was found. We have a content injection threat against the web application component again, and there's the code it was found. We have some acceptances, so we're accepting some arbitrary file rights. We're not going to mitigate that. We're accepting that those file permissions are sufficiently restrictive. So whilst, yes, potentially there is a threat associated with that file right, we're accepting that threat. We could potentially reference this to a JIRA story or a risk in some risk database somewhere. We have some mitigations as well. So we are mitigating against some access abuse of the web component by using some basic input validation. We're mitigating against privilege escalation by using a non-privileged port, et cetera, et cetera. And we're also creating some tests as well, which I won't really go into here. And again, as I said, you don't necessarily know whether something's a threat, whether something's a mitigation, what state it's in. So you've got this review tag that you can say, you can use to ask questions. You can say, we need to come back to this. We need to understand this. So there's a review here, which is, I don't know what this line of code means. Is this a security feature? And somebody can, that can spark off a conversation. And again, maybe we link this to a JIRA story or something. And we also have the table of different components and connections, etc. And those where we have the threats in the threat library, we've got some of those key attributes in key value pairs. So that's kind of what you get from ThreatSpec out of the box. I'm halfway through a major rewrite of the way it stores data internally, because what I want to be able to do is be able to query. I want to be able to tag certain threats and components and say, show me where you've got a big threat model, just show me any threats associated with AWS, or show me all the CI/CD threats. So being able to create that kind of query, I think, would be quite a useful feature to sort of narrow down some of these complex diagrams as they get, as your threat models get bigger and bigger, these diagrams get more and more unwieldy. So that's fine, but if you can hone in on certain things as and when you need to, then I think that's a better way of narrowing down the scope as an interpretation than trying to narrow down the scope as an input to the process, if that makes sense. That was pretty much it I have for me, to be honest. Any questions?
Any questions?
So I'll go back to my code home. Again, so there are some interesting opportunities for tying this to other approaches. What I like about the PYTM is the powerful descriptive nature of that approach. Is Izar's basically created a domain-specific language. Maybe there's opportunities to sort of create some synergy between threat spec and that approach, and possibly threat playbook as well. I think we've had some conversations in the background. There may be people may have some interesting ideas about how we can reuse or re-expand on some of these tools working together.
You just stole my question. I was going to ask something like that.
Yeah, again, this is very experimental. Your mileage may vary. Have a play with it. Let me know. There's probably quite a few bugs.
So do you also have a GitHub repo for this?
Yeah, so I mean, it's probably easier just to go to threatspec.org. There's a link to the repository right at the top. As you can see, it's nearly a year since that update. Time flies. you just.
And how should people approach you if they want to contribute?
The easiest is probably hit me up on Slack, OWASP Slack, or on Twitter. My handle Wierckx10 is, just Google that. You'll probably find me. It's at Wierckx10 on Twitter and probably Wierckx10 on OWASP Slack. Or like reach out via the Git repository. In fact, I wonder if there's a help thing. Yeah, no, probably easiest to do it via the code. Thank you.
Thanks a lot.
So let me also thank you, Fraser, for all the work that you've done on it. Again, this is an open source tool, so I can imagine you spend quite an amount of your free time on this as well.
Yeah, when I have it.
Okie dokie. Any further questions? I guess not. Okay. Does anybody else want to demo anything else? Because we're here, like 16 of us. I'm sure we can all learn from each other. If anybody wants to discuss anything about threat modeling, because we do, our sessions are normally 2 hours long. So we are coming to the top of the hour and we're done. But we can use this extra time to contribute to each other. Tough crowd, huh?
So I could potentially spark off a controversial debate. How do people feel about threat modeling, the automation of threat modeling versus the human element of threat modeling?
I would say that automation is hard. So this is the kind of problem that humans might not do perfectly, but good enough. It's like comparing to the solutions of traveling salesman problem. This is solved. I mean, computers can solve this pretty good, but for a low number of nodes. With a high number of nodes, the computing power required is significant, and humans will not find a perfect solution, but will do a pretty good job, and very often good enough job that this is acceptable. So I find this as a good analogy to threat modeling, that we might not build perfect models and identify all the threats, but we can find most of them and the biggest ones, and that's usually good enough. So I'm trying to use PyTM to automate it in some way, but I'm starting. I'm doing the minimum absolute things possible. So I'm not trying to automate everything using PyTM. I just want to improve the whole process in any way possible.
Right. So what is it you're trying to? What is it that the automation simplifies for you then?
Currently, I think regressions mostly to catch any regressions. So if we, it's less about finding new threats or unknown threats, but rather if we do identify a threat in one part of the system, that the tool should help us find the same threat in other places.
Yes, that's a nice way of putting it. Yeah, sort of cross-functional regression testing.
So the thing I think that we have to consider here is that at the end of the day, threat modeling is and will always be a conceptual exercise. So the problems that I saw as a security practitioner was that going to teams and saying, hey, from now on, you're going to do this thing called threat modeling, and here's the methodology that we think you're going to use. And you hit that barrier that people either look at the methodology itself and say, that's too heavy, I have no idea where to begin, or they lack that security background to conceptualize the idea of threat modeling from the beginning. So those are two sort of like deer in the headlights paralysis states that you get. And I think that introducing PyTM, it was mostly an answer to the Microsoft tool that's out there for so many years. And that people look at it and see, okay, first of all, this thing is Windows only. Second, it's huge. Third, I have no clue what I'm doing. And fourth, I get 400,000 threats, and I don't know how to deal with this whole thing. So we tried to just give a tool that would put people on their way. And we hope that at some point, sure, that the automatization is great for maintaining the documents and maintaining the stuff running together with the system as it develops. But we hope that people will step out of those boundaries of those pre-cooked threats that the tool identifies and start thinking in more conceptual terms, saying, okay, these are the things that, yeah, okay, so I'm not using TLS. Fine, from now on, I'm going to use TLS, and that's going to be great. But what are the threats to my business process? What are the threats to my data? What are the threats that are inherent to my system as my system? Privacy, all that stuff that makes, that attacks the crown jewels of the thing that I'm developing. So at some point, I would hope that people would step out of the pre-cooked threats that all the tools do and move more towards the threat spec model, where they recognize, hey, I have something here that's inherent to my system and my code. I'm going to document it here so that later on it's easier for us to see that, yes, it was approached the right way, or we have to modify this. Does that make any sense out of my head?
Yeah, so that's I think we're coming from exactly the same position. I think the challenge I have to some of the automation approaches to threat modeling is I always feel like they're trying to automate humans out of the process. Particularly healthy. I think you want to you try and do the heavy lifting as much as possible without adding cognitive burden onto the users. So asking them to draw a diagram and then giving them 1,000 threats or 1,000 controls to go and look at is not reducing cognitive load on them. That is giving them more stresses and anxieties and things like that. It's just going to turn them off doing threat modeling. But simply saying, as you're saying, what's the business process? What are the things that can go wrong? Just keeping true to that threat modeling methodology, and then using automation to sort of augment that process and to streamline it and to make it a bit more consistent and to do some of that heavy lifting, I think that to me feels like the more natural direction to take it, not in reverse.
Or the
I'd like
automation.
to expand on that. So considering we looked at two tools that touch on code, so threat modeling with code. If you start from a code perspective, there is a reason we still have developers. So there are code generation tools. They can generate framework-related things, generic-related things. The same thing happens in threat modeling. Like if you create a web application and you use the standard Azure or AWS architecture for it, that threat model has been made. You don't need to redo it. So you take that threat model, you look at the things that you did differently, or you look at only your specific business logic, and that's how the automation can actually help you. We don't have the AI available to actually do an automated threat model. If that would at all ever be possible, is probably in a lot of years, yes, but not in the foreseeable future. That's how I look at it.
Yeah.
So I'm not an expert in this field, obviously. So we have seen two demos, as Steven said, about the code. But how about the data flow diagrams? Is there any automation that's doing any threat modeling on those? And how can you have a threat model if you can't see the data flow diagram?
So I think Jeff's talking in the next session probably about something more related to that. On behalf of Threat Spec, for me, that's about creating feedback loops. You define some components in those connections in your code. You can then generate the report that, and the same with PyTM, right? You can then generate what that picture looks like. You can then threat model that as a team or as an individual. That will then change your interpretation. You add some more components, you add some more threats, and you generate a new view, an updated view, and you look at that again and you go, well, now in this context, I'm actually thinking about this and this and this. You go back to your code. And so you're creating feedback loop between the code and those diagrams. It's not, here's a pristine, perfect diagram, go and threat model it. It's how do we evolve that diagram along with the code over time in both directions.
Yeah, I think we also need to take a small step back when we talk about diagrams. Diagram has no purpose by itself. What you're actually trying to achieve is to speak the same language and have a clear view on the scope, what it is you're building. Yeah. You can do that without a data flow diagram, for example, by writing a bunch of user stories, and the people involved in the threat model understand what they're building, then you don't need a data flow diagram. You just need to make sure that everybody understands what this thing is that you're building. The scope is clear. So I see a number of people that are beginning in threat modeling get hung up by the diagrams. Diagramming is just a tool to talk to each other, to understand the scope and note that down for posteriority. You can do exactly the same in code. If you do it in plant UML, you can still generate a diagram. If you do it in user stories, it works equally fine. So we just need to realize that most of the threat model methodologies out there have this step just to make sure that everybody speaks the same language and you can clearly define a scope. That's the whole purpose of the data flow.
Exactly, and there's also the fact that there are people who are visual by nature. There are those who are not. So it's good to have options of people being able to describe their system in something that's more natural to them, which is code, and then generate that diagram. And then, as Steven said, be able to look at it and say, yeah, this is the system that I'm trying to model. And especially now with everybody working remote and whatnot, we have seen use cases for ITM where people get into that initial discussion of, okay, what is the system going to look like? And the picture that most of us have in our head is a meeting room and everybody around one table, and there is this whiteboard in front of it and somebody furiously drawing and erasing on it. But what happens at the end of the meeting? Somebody takes a picture of that and goes and redoes the thing in Visio or something like that. And it's good to be able to offer a tool that takes away from that loop of taking a picture of the thing and redoing the thing in another tool, and basically gives you something that you can work with straight out of the meeting. So both the practical side and the more human side of how you represent that system and how do you recognize that system as yours should be covered by all tools. Not saying that there is anything inherently bad with tools that focus on one side or the other side. We have both the questionnaire-based tools and we have tools that are based on drawing the diagram and then annotating it. But it's good, as Fraser said, to have that loop, to be able to feed the thing continuously.
So that then extends my question into user stories as well. Is there a way to do automated threat modeling on user stories? Do you know? Have you come across anything?
Well, shameless plug. I worked on something called continuous threat modeling that basically goes into threat model every story, and that's open source too. That's on the Autodesk repo on GitHub. And that's basically a way to bring the practice of threat modeling to every single developer story at some level. So I'm not quite sure if that 100% answers your question, but I think it's quite proximate. So tools perhaps will make things easier, will make things more practical. But in that sense, I would look at something more on the descriptive side and documentation side of the practice than in actually using a tool to elicit more threats or new threats.
Thank you.
Can I just jump in for a second? I want to point out that threat modeling is inherently a design activity, and software design is, you can't automate software design. You can automate some parts of it. As Izar was saying, you can have some automation to help you with some of it. You can manage it and plug it into the pipeline in a lot of ways. But the entire threat modeling will never be able to be fully automated.
Yep.
It can be integrated, though.
I mean, there have been I think that academic approaches to formal model description languages, but at the end of the day, to me at least, that's just taking one step back and using one language to describe another. So it could be that the same problems that you would end up having in the initial design, you would have when using those modeling languages. So there is some research in that way, but I don't think that it's usable right now.
No, you're quite right. I've not seen anything out of the academic community to hint towards that. And even if you look at let's say the AI-generated designs, so I know that Intel is using an AI to design new chips, which is doing better than human design, but that is such a niche product. It's so difficult to generalize that even if you could automate the threat model for one very specific thing, it will be very difficult to generalize that into a tool that could do threat modeling on anything, because we can do threat modeling on a piece of software, on hardware, on a process, a combination of all of them. So it's going to come at some point, I think, when we have AGI, so a general artificial intelligence, but that is, I'm thinking like at least 50 years off now.
And it might be a similar challenge the pen testers had in the recent years. Do you automate everything, or do you still need the human element? And they're probably facing similar challenges in there.
I think you touched a point here in the. Go ahead, Avi.
You go ahead.
No, you first.
I was just gonna say, I don't think pen testers have that, because a huge amount of pen testing can and should and is starting to be mostly automated. Where pen testing can't be automated, it's really on the edge cases, and that really comes back to, I would say, hands-on threat modeling, right? And that's the only real part of the pen testing that can't be automated.
It's the business rules and these kinds of things.
I would build on that, on what Avi just said, and say that the point here in both fields is creativity. So you're creating a new thing, and you're looking to elicit threats against it that go out of that checklist that everybody uses. And you are trying to break into something, and you are trying to elicit different threats and different vectors in there that go away from what everybody automates. So that creativity is not going to be automated anytime soon.
I agree. Any more questions? Any other controversial topics?
Emacs or Vim?
Sorry?
Nothing.
So I know threat modeling is a design stage activity, and I haven't done much threat modeling myself. I'm ashamed to say it as a security professional, but I did not have the chance to do it yet. So when you find, I don't want to say vulnerabilities, when you find the threats, what is it usually fixed with? Is it usually fixed with the code, or do you need to do further stuff than just change recoding?
Well, since it's a design activity, that the preference is to fix it with design. So if you can go and remove a whole class of threats by changing the design, much better. Of course, because it is mainly a design practice, but it happens at any time. You could end up having to change code and even having to change, I don't know,
architecture
component or something like that. Architecture would be better to catch it at the design step. It would be much more expensive to do it afterwards.
Mm-hmm.
But
the thread modeling exercise might make you rethink your bits of your architecture, maybe, right?
At the end of the day, that would be the best outcome if it happened at design time, I think, my personal approach.
Cool. Any other questions? It has been quite useful for me. It's like been a training session for my benefit. So
actually, just one comment, perhaps people will agree with me or not. You said that you haven't had much opportunity to threat model. Mm-hmm. As a security practitioner, I would put forward that you have, you just didn't notice. Because when we look at the process of threat modeling, is a much more natural thing than we think once we step back and look at it as methodologies or, I don't know, fixed ways of doing it. It's basically something that we are doing the whole time as security practitioners and developers.
I am a risk manager, so my life is about finding the stuff and helping people to fix it. But what I meant is that I didn't have an official session where I called it a threat modeling and put people in a room and went through the stuff. It's usually...
Oh, try, it's fun.
I will.
Bring lots of popcorn.
Okay, so people have... people are dropping off one by one, so I think I will stop the share on YouTube now. And if we, with the rest of us, the 13 participants left, if we want to discuss anything, we can continue discussing. Thank you, Izar. Thank you, Fraser.
Thank you.
Thank you, Stephen, so much. And see you in the next session.